10.2, simplifying radicals. This is something you guys probably seen a little bit 8th grade math. I think you guys won't have too much problem with it. We'll see. To simplify radicals involving products and quotients is our objective. Vocab, radical expression is an expression that contains a radical. Pretty no-brainer there, I guess. Rationalize the denominator, remove the radical from the denominator. That is not the definition the book gave you. That is the definition I gave you. A radical expression is simplified if the following statements are true. The radicand has no perfect square factors other than 1. The radicand contains no fractions. And I put that there twice. No radicals appear in the denominator of a fraction. So, another property before we get going into this. For multiplication property of square roots, algebra, for a greater than or equal 0, square roots AB equals A squared times square root of B. So square root of A times the square root of B. Example, square root of 48 equals the square root of 16 times the square root of 3. You just can multiply these two. We broke them apart. That's what we were working with when we were trying to simplify square roots. So we're basically doing the same thing here and proving it. So this would have been square root of AB equals square root A times the square root of B. Okay? So, what is the simplest form of square root of 160? Well, I'm going to go with the square root of I'm trying to think what I want to break this apart into. At first I was trying to do 116, but that doesn't work out because of the fact that that would give me 1600 or 1060. We can do 10. We can do 16 and 10. Okay. So can we simplify this? Well, can we take the square root of 16? Yes, we can. It'd be 4. Can we take the square root of 10? Can we break 10 down any? No. So our answer is 4 square root 10. 72. So we got the square root of 72. I'm thinking square root of 9 times the square root of 8. Doesn't mean you have to do that, but I'm looking for something that has a square root that is a factor. This one actually could have been a little better job by me. But you get 3. Can you take this down? Well, you can go 4 and 2. And you can get square root of that and square root of that. So you'd end up with, or breaking this down, square root of 8 equals square root of 4 times the square root of 2. So you'd have 3 times 2 times square root of 2. So you'd end up with 6 square root 3. Okay. Removing variable factors. Okay. So, this I'm going to do the same thing I was kind of doing in the last one. Square roots. I'm trying to think of how Mrs. Mentley did this last year. You get the square root of 54n to the 7th. Trying to think. You can do 9 and 6. I'm going to figure out what even numbers can be square rooted when it comes to exponents. So I'm going to go with 9n to the 6th square root times 6, or square root of 6n. This is n to the first, which means I don't have a group of 2 to get rid of. 6 is only 2 and 3, which you can't simplify that anymore. But I can simplify this, and I should get 3n to the 3rd times square root of 6n. And that would be your answer. Okay? I know I'm not doing a great job of really going straight into the details, so let's try to do it a little better on this one. You have negative m times the square root of 80m to the 9th. Okay? I'm trying to think of something that goes in there decent. I keep coming up with 4 and 20. You could go 8 and 10. I think 16 would go in there 5 times. I'm going to go with 16. So 16, because that's a perfect square. Looking for m, well, I need an even one, so I'm going to take m to the 8th. So I'm going to subtract 1 to get down to the one that I need. You have negative m. What leaves me times the square root of 5m. Okay, if I bring this down, I'm going to get 4m to the 4th times square root of 5m. Now don't forget about this negative m here. Technically this is like having a negative 1 there. Having a negative 1 then makes negative 1 times 4, which is negative 4. M, when you have common variables and you're multiplying, you add the exponents, m to the 5th times square root 5m. Okay. Okay, multiplying two radicals. Okay, so we have 3 square root 6 times the square root of 18. Now, before I can multiply these together, I have to have what's in the radical be the same, because it's like having x's. This would be like having an x and a y. I can't combine those. So let's see. Can we do 9 and 2? Well, I could do this together. Actually, I take back what I stated. You can multiply these two together. And you can multiply what's out in front of them together. Which in this case, there wouldn't be anything. So, the only thing that I'm saying here is I'm probably going to go this route for one reason only. When I do this, I'm going to end up with square root of 6 times 3 square root of 2. It just made my numbers smaller and easier to work with. So I get 9 square root of 12 when I multiply these together, because I could take the what's in front of them together, and I can multiply what's in the radical the same, because when you're in the radical, it's like being the same thing. You can multiply them together. This is going to be, can be made up of square root of 4 and the square root of 2. This has got to come down. This is 2. This is 9 square root 18 square root 2. Okay. Okay, you can give this one a shot on your own if you want. You get the square root of 2a times the square root of 9a to the 3rd. So when I multiply these together, I'm going to get 18a to the 4th. Okay, going back up to what we were doing on top, I'm going to take a 9 out of this, square root of 9. I'm going to look for an even one of those, which is 4, leaving me no a's left, so times square root 2. Take that, you're going to get 9, so if you take the square root of 9, you get 3. Take the square root of a to the 4th, and that would be a to the 2nd times square root 2. There's your answer for that. Okay, now we have 7 square root 5x times 3 square root 20x to the 5th. Okay, if you multiply that together, you're going to get 21 square root 100x to the 6th. Now, in this case, I know if I take that, I'm going to bring down my 21, times that by what I can bring out. Well, I can bring out this, which square root of 100 is 10. Square root of x to the 6th is x to the 3rd. So I'd multiply those together and I get 210x to the 3rd is an answer. There you go. Okay. Last kind of thing we got to go over is I feel like that doesn't go with this one. It does not. What did I do with the one I need? Or did I keep something in there I shouldn't have? Writing a rational expression? Okay, maybe I did have this one in there. Okay, so you want to get this through a door. Okay, we can do this. Rectangle door in a museum is 3 times as tall as it is wide. So what is the simplified expression for the maximum height of a painting that'll fit through this door? Well, your door looks like this. Okay, your height is whatever W is times 3, so 3W. Okay, so you know it's 3W. Okay. So we have to use Pythagorean theorem to find out what this diagonal is, because we could always put it diagonal, and that's going to be the longest part it could be. So if you went W to the 2nd plus 3W, and that's all to the 2nd, equals C. Okay, what you got going on here is you have W to the 2nd plus 9W to the 2nd equals C to the 2nd. Okay. Now add these together. Well, this is like having 1 W to the 2nd, so that's going to give me 10 W to the 2nd equals C to the 2nd. Square root both sides. You're going to end up with C equals W square root 10. And I think that is your simplest equation, or simplest form. So that's all the bigger that your picture can be. We obviously need to know what our width of our door is to plug into this formula. But this would create a formula if you ever had something like this where you're trying to get through there. Simplifying with radicals. Okay. Okay. And they talk about the division thing, and I'm guessing that's what was supposed to go here, and then I never put it there. What you got going on here is you have the square root. So you got the square root. I should make that bigger. Square root of 144 over 9. Well, that means each one of these is square root. So you could break this down and make it square root 144 over the square root of 9. That equals the square root, or equals 12 over 3, which equals 4. So 4 would be your answer there. Okay. Now, the other thing we can do is this part B, or B. So where we get the square root of 36a over, and I'm just going to break it into square root over square root a to the third. Okay, if we're up top, this is a to the first, which isn't an even exponent, so we can't take the square root of it. So we're going to end up with 6 square root a, because we know the square root of 36 is 6, over, okay, now we have 4. Well, we can take the square root of 4, that's 2. A to the third, we can't do that, but can we take a to the second? Yes, it comes out once. So you have 2a square root a. Okay, now can you simplify anything here? Well, technically this and this cancel out. So this does what leaves you 3 up top, which is 3 over a. Here's your answer for that one. Part B, you have 25y to the third square root, and technically everything's in a square root, so I'm just going to break it apart right away. And you have z to the second. Okay, up top, can we take the square root of 25? Yes, we can. It's 5. Square root, can we take y to the third? Well, no, because it's not even, but we can take y to the second, which then just gets us y out here, which leaves us 1y in the square root. Z to the second, if we square root that, we're just going to end up with z out here. And there's our answer for that one. Okay. What is the simplest form of each radical expression? You have the square root. And this is going to kind of go in the same way. So you have the square root of 2 over the square root of 3. Can we take the square root of 3? No. Not unless you're going to get a decimal. So we need to get this in simplest form. We have to multiply and get the radical out of the denominator. If we multiply the radical by itself, we should get it out of there. So if we take the square root of 3 times the square root of 3, we should get the square root of 9. And up here, we should get the square root of 6. So we should end up getting the square root of 6 over the square root of 9. Can we take the square root of 9? Yes, we can get 3 over the square root of 6. There is our answer for that one. Okay. On this bottom one, we have the square root of 5 over the square root of 18m. Now, this time you could multiply it by 18m. That would work out fine. I'm not going to go quite that far because I know 18 times 2 equals 36. So I'm going to take this times the square root of 2m. What I do to the bottom, I must do to the top, which is 2m. So we ended up with square root of 10m over the square root of 36m to the second. Can I simplify this bottom? Well, yes, 36 is 6. M to the second square root is just m. So you get the square root of 10m over the square root, or over 6m. That is our simplest form for B. C is the square root of 7s over 3. This is all like that, which is what we were just working with over here. We're going to have square root of 7s equals square root of 3 times by the square root of 3 to get that to 9, because that gets me to a perfect square. You're going to get square root of 21s over square root of 9. The bottom, if you take the square root of 9, you get 3 over the square, or 21s. Square root of 21s over 3 should be your answer. Nothing too extreme there. There's your homework.